This is lesson 3-5. We're in Algebra 2 today on this beautiful November 7th. So we are writing November 7th, 11/7. Long division. So yesterday we did long division by a monomial. So what is a binomial again with a quiet raised hand? Steph? Two terms, yeah. So let's come over here to Steph. It has two terms in it. It's a polynomial with two terms. There you are, 50x, be nice. So when we look at our division problem, are we okay?
Yeah.
All right. When we look at our division problem, it is the equivalent of dividing something with two digits. I have a tens digit, a ones digit. I have two terms, an x term or a degree 1 term or a degree 0 term. So let's go ahead and practice just dividing 136 by 11. Let's see if we remember how to do our long division from, I don't know, like second grade. When do we learn how to do this? Forever ago? Definitely preschool. All right, so 11 goes into something, something. Help me out. What's the process? James, go for it.
11 goes into 13 one time.
One time. And notice where I'm writing my 1. I don't write my 1 here. I write it over the 3 because 11 goes into the 13. I write it to the rightmost digit. And then I say, okay, 11 goes into 13 once. Then what do I do next, James? I write the 1 here, and then I...
11 from 13.
Yeah, so I have that 11 here because 1 times 11 is 11. And then I subtract. I multiply everything here by -1. That multiplying by -1 is where it gets tricky today. Let's remember to do that. Let's remember to not make that common error. So 13 minus 11, I will tell you that's 2. You're welcome. And let me come back here and give James his XP before I forget. There you are, James. All right, and now I'm going to do what? I need the next few steps. There I go.
You bring down the 6.
Bring down the 6. So I have 26, and then oop, that's a 6 there. And what's the next step, Stego?
See how many times 11 goes into 26. Literally goes in twice.
Twice.
Subtract 22.
Subtract 22. Nice. And we'll give it to someone else for the next step. Thank you, Stego. Why is this not alphabetized? There we go. Stego, there you are.
I'm last.
And my final step, quiet raised hand, quiet raised hand, quiet raised hand. Andre?
Your remainder is 4.
My remainder is 4. So I write this as 12 and 4 over 11. Because I subtract those, my remainder is 4. We'll write this remainder. Remainder is 4. So I write it as 4/11. So the answer here is 12 and 4/11. We remember how to do this from, I really wish I knew when I learned this, but I have no idea. I would guess, I would say like, yeah, 2nd or 3rd grade is when I roughly remember doing that. All right, x plus 1. So notice the similarities here. This was 1x plus 1. This was 110 plus 1. Notice that there is 1x squared, 3 x's, and 6 1s. 1 100s, 3 10s, and 6 1s. There's a very similar relationship here. Let's see how they compare. First, I'm going to do what? Quiet raised hand. See if you can apply what you did over here to our new scenario. I'm curious into seeing what you think we should do. Fiona?
How many x's go into x squared?
Yeah, how many x's? We're going to look at that first term. How many x's go into that x squared? And how many is that? How many x's do go into x squared?
2. 1. X. 3.
X.
amount.
X. And where should I write the x? Should I write it here, 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 the first, second, or third? Where do I write the x?
Above the 6.
Good guess, but no. I'm going to write it right here. So, and this was kind of my mistake from yesterday. I should always be writing it with the same digit. So if I have an x here, I should have an x above here. So when I do that, x plus 1 goes into this whole term, x squared plus 3x, x times. And now what I'm going to do is I'm going to multiply everything here, x plus 1, by x. And I'm going to write it underneath here. So before I move too far, Fiona, thank you for participating. How am I going to do that? What is x times x plus 1? Can someone give me a quiet raised hand? How do I multiply this by this? This x by x plus 1. Only Fiona knows? Andrea knows. No one else knows? All right, Chris, thank you. How do I multiply x times x plus 1?
How do you what?
It's either you or Eva because you two haven't participated yet. I call on you though, Chris. So try it out.
Wait, so how do I do what? What was the question?
Multiply this x times x plus 1. So distribute the x.
X.
X times x is?
X.
No, it's not. Try again.
2.
Good guess. You're close
Dude,
to
I
it,
don't know.
but try again. X times x, Chris.
2x. X squared. Something squared.
X squared, there it is. Because it's x to the power of 1 times x to the power of 1, you add the exponents. Now x times 1, Chris, is? X. So this is x squared plus x. Everyone has this down in your notes. Okay, here is the trick now. Everything here is being subtracted from x squared plus 3x. So I need to write a minus and a minus. You don't have to erase anything. You just add the additional minus. And if there was a minus sign, you can turn it into a plus. We are subtracting everything here. Let's go ahead and see what happens when we subtract. When I subtract x squared from x squared with a quiet raised hand, what happens, Eva? Those cancel each other out. What about this one? 3x minus 1x is?
2x.
2x. Nice, thank you. Eva, 50 XP. All right. What's my next step? Quiet raised hand. Stego. Bring down the what? The plus 6. So we're going to bring it down, plus 6. And my new question for us is, what is the question? What is the question you need to be asking yourselves? Something about this, something about this. What is the question? What is the answer? I need to know both of those parts. I'll start your question. How?
It's 2x plus 6 over x plus 9.
How? Stego has an answer and a question. James, go for it.
Would x plus 1 go into 2x plus 6 twice?
It does, yeah. And so the question is, how many times does x plus 1 go into 2x plus 6? And you told me twice, and that is correct. I write the 2 above the 0 degree, 1 degree, 2 degree. So x plus 2. And when I multiply 2 times x plus 1, James, what am I going to get here?
2x plus 2.
2x plus 2. You're correct. Yeah, so just 2 times x plus 1. We'll give it to someone else for the next few steps. Thank you, James. What are my next few steps? Eva. The positive 2. Yeah, we just did that, sorry.
So you just subtract everything.
Subtract everything to get what?
4.
Those cancel out. And you're left with 4. Okay. And Eva, I'm going to give it to you one more time. What do I do next? What do I do with that 4?
4 over x.
There it is. Plus 4 over x plus 1. There's our final answer. Thank you, Eva.
I don't like that.
Don't like new things? New things make you always feel younger
You know what
than if you don't do anything new.
Mental abuse to humans.
I did not know that. I learned something new today. Thank you for that. All right, so are there questions how to do this? We're going to try a really, really hard example right off the get-go. This is harder than you will ever see on the test, harder than you'll ever see on the quiz, harder than you will ever see on the homework, but it's a good example. So let's do it. This example right here. Yeah. You have to be really, really, really fast. All right, so let's go ahead and set up our problem. Again, and I'm talking to you, Chris, because you made this mistake last time. Leave space right here. Don't write anything on this next line. Skip a line and go ahead and write down x minus 3. Do this thing. It's going to be long. And I am going to just start off by writing only one of them because something interesting is going to happen. So don't write all of it. If you're writing all of it, you're going to have to erase. Don't write all of it. Something interesting is going to happen. I'm just going to write my first term. Something interesting is going to happen. All right. You guys are walking me through this problem. What am I doing? What's the question? What's the answer, Fiona?
How many times does x minus 3 go to 2x?
Yes, and how many times does that go into 2x to the power 5? How many times? What's the answer? Say it again. 2x to the power of...
2.
You want to call on someone else to help?
4?
It is 2x to the power 4. But notice, if I were to, and please don't write this, if I were to write minus x to the power 3, where would I write this 2x to the power 4? I'd have to write it in between these. So what I'm going to do here is I'm going to skip a space. Here's my skipped space. My skipped space, and now I'm going to write my minus x to the power of 3. I can now write Fiona's 2x to the power of 4 above the 4th degree area. There's this null space. Well, not really null space. That's a linear algebra term. But this empty space to make sure that we have a placeholder. All right, when I multiply 2x to the power of 4 times x minus 3, Fiona, just to continue it off, 2x to the power of 4 times x minus 3, you're distributing that 2x to the power of 4 into each of these terms. What do you get?
2x to the 5th
Minus 3 what?
x.
Again, you're multiplying negative 3 times 2x to the power of 4.
Oh, negative 6x to the 4th.
Negative 6x to the 4th. And notice here, by having this empty space, we now have an x to the power of 4 where there was no x to the power of 4. We can actually see what's going on here. In fact, if I was being formal about this, instead of just skipping a space, I could actually say this, and you don't have to write this. This is just to explain a point. You could have written plus 0x to the power of 4, because anything times 0 is 0. That's what's happening here. So, my next step, someone aside from Fiona, she just did a lot of heavy lifting there. Working out that brain. What is my next step? Go for it, Andre. You subtract it. So I'm going to subtract, and I'm going to add this one because I changed the sign of both of them. And what do I get, Andrea? It is just 6x to the power of 4. These cancel each other out, and I'm adding 6x to the power of 4 to no x to the power of 4, to 0x to the power of 4. So this is just positive 6x to the power of 4. All right. Now that we know that we shouldn't accidentally skip a degree, go ahead and write in the rest of this without skipping any more degrees. And I don't think we have any problems with it. It goes 3rd degree, 2nd degree, 1st degree, 0th degree. We can just write the rest of this out. So minus x to the power of 3 plus 3x squared minus 2x plus 7. And that's a big problem, Mr. Sindel. Here we go. Hopefully we get every single person participating on this problem. It's like a team fight, taking down this boss. All right. My next step, did I give Andrea her XP? I did not. My next step is to do what? Someone new on this problem. So far, Fiona and Andrea have participated in slaying this dragon. Next is Eva. Take your turn.
Bring down the negative x.
Okay, and what's the question I'm going to ask?
How many times does x minus 3 go into 6x to the 4th minus x cubed?
Okay, and what's your answer to that question? Chris, can you please not?
Is it plus 6x cubed?
Plus 6x cubed it is. Because when I multiply 6x cubed by x minus 3, I will be able to cancel out this term once it turns negative. And Eva, you are almost done. Your last step for us is to tell us what happens when you multiply 6x to the power of 3 times x minus 3. What do you get?
You get 6x to the power of 4 minus 18x to the power of 3.
3. There it is. Okay. Thank you, Eva. All right. 3 people have taken their turn slaying this dragon. We need 4 other people to help us out. 4 new voices. What am I going to do next? What is the next step? Steph, go for it.
You subtract
Subtract, subtract, boom, and what do we get?
17. Oh, those cancel out.
Those cancel out.
And then it's 17x
Cubed, okay, I agree. Thank you. And can you just go ahead and do the next step, and then we can give it off to someone else? Yep, bring it down. So bring this down plus 3x squared. All right, thank you, Steph. I still have not heard from 3 people on this problem. One of those 3 people needs to speak now. So I believe those 3 people are Stego, James, and Chris. Stego, James, and Chris, one of you 3 has to participate on this one. Go for it, Stego.
You have to find out how many times x minus 3 goes into 12x.
A 12x or 17?
17x.
Okay, yeah. Okay, so that's a good question, a great question. And what's the answer to your great question?
I don't know how to get it.
I'll tell you a hint. Notice that when we were trying to figure out how many times we went into 6x to the power of 4, we went 6x to the power of something. So if I'm trying to go into 17x to the power of something, what do you think your coefficient is going to be? It is going to be 17. X, it is x to the second. Yeah, you got it. Perfect. Go ahead and write down, everyone. 17x to the power of 2. I'm writing it above the degree 2 term. And Stego, sorry, you are not done because you now need to distribute this 17x to the power of 2 into this x minus 3. And we know that we should get this first term exactly because we're trying to cancel it out. Power of 3. Continue on. 17 times 3. You might have to do it on the side of the paper. You want Mr. Sindel to do it really quick for you? 17 times 3. 7 times 3. 21. 21. 3 times 1 is 3. Plus 2 is 5. The answer is 51. Second. Perfect. Yeah, good job, Sego. You definitely deserve that XP. All right, that means it's James and Chris. One of you 2 needs to help slay this dragon, this huge beast of a problem. Go for it, James.
Bring out the -2x.
Ooh, careful before you do that.
Oh. Yeah, we have to subtract the 17x over 3 and 31x squared.
Okay, and what do you get? 48.
-48x squared.
48x squared. All right, there it is. Is there an error? Is that why we're raising our hands? All right, I will give it to Eva.
It's supposed to be positive 54x squared because it's negative 51x squared, and then when you do the subtracting, it turns into a positive instead of a negative. You put it as positive already because it's negative 3 times 17.
Ah, yeah, so let's take a look at this. So what we should have written here is we should have originally written, why does that do it? I don't know. If you scroll down and up again, it fixes it though. We should have written minus 51x squared because a negative 3 times a 17 is a negative 51. And then after we switch it to a negative, then it becomes positive, which means now, James, you want to try it again? What is 51x squared plus 3x squared?
54x squared.
I don't know what does that. It is indeed 54x squared. Good catch, Eva. Go ahead and log it. James, 50 XP. Eva, you got 70 XP. And you got an extra credit point. Make sure to log it. What next? What is the next step? Actually, James, can you just finish off this last step? I know that you were about to say it anyway.
Bring down -2x.
Bring it down. So bring down this negative 2x. I'm going to switch to yellow here. Bring down this negative 2x. All right, Chris, it's on you, man. You have to do this one. You're the last one. You have not participated in slaying this beast of a problem. Ask me a good question. Something about x minus 3.
You have to see how many times x minus 3 goes into that number.
Yes, this binomial.
54x squared minus 2.
Okay, and what is the answer to that question? Positive or negative? Positive 54x, I agree. And you're almost done, Chris. You now need to do 54x squared. Wait a sec. You said x, not x squared, didn't you? Oops. 54x, multiply 54x times x, then do 54x times negative 3. Tell me what you get. Distribute that 54x into both of these terms. What do you get? You got this, Chris. 54x times x.
Wait. It's 54x squared.
Good. Next one is,
162. I don't know.
is it minus or positive?
Minus
Minus 162 what?
x.
X. All right, there it is. Good job, Chris. All right, it's fair game for anyone. What's the next step? Let's go fast and just finish this one off. Fiona, go for it.
You have to subtract them, so it's 160x.
160x. All right.
And then bring down the 7.
Then bring down the 7.
And it goes in 160.
160. So plus 160. And now I'll get rid of the x's. And I have to do 160 times x and 160 times negative 3. So I do that and I get 160x. What is 160 times 3? Nice. It is. Negative 480. We need to subtract them. Subtract, subtract. And my remainder is, we ran out of room here, 487. So plus 487, all divided by x minus 3. Well done. This type of problem is on Khan Academy. The reason that I chose this giant beast was A, to make sure that everyone would participate on one problem, and B, to show you why synthetic division is so amazing. I can solve this problem in 1/4 the amount of time that we just did, with far less space. I'm going to do the same problem, but with synthetic division. I only need this amount of space here for synthetic division. That's how easy it is. Here we go. By the way, synthetic division only works on certain types of problems. Synthetic division only works when the binomial coefficient of the x term is 1. For example, if I look, I'll keep that up here. If I look at this one, the coefficient of this x was 1, so it works. Synthetic division will work. If I have 2x minus 3, it no longer works. So if ever on Khan Academy you see a 2x minus 3, you have to do it the long, old-fashioned method that we just did right here. But normally, what I plan to have you do is use synthetic division as much as possible. Are you guys ready for it? Here's how you set up synthetic division. First, make sure that you write down every single degree. Don't skip a degree. Just like we did here, the degree of our x to the power 4 term, or sorry, our degree 4 term, the coefficient is 0. I'm going to write down each coefficient. Here we go. Each coefficient looks like this. 2, then 0, then -1, then 3.
So can I move your lunchbox?
Oh yeah, I should do that. -2 and 7. I wrote each of the coefficients. Notice that you have to have this 0 as a placeholder. That's where you're going to make a mistake. I guarantee one of us will make that mistake. Go ahead and circle that to let you know that don't forget that step. Always remember to have a placeholder value. The next step is to write down this term, but the multiplied by -1 version. So if I multiply -3 by -1, I get, shut it out.
-4.
No,
-3.
+3. That +3 I'm going to write right here, and I do a little box to let me know I'm not actually talking about the polynomial over here. All right, my first step is to draw this line right here. All right, we are now set up for synthetic division. And here it goes. It's easier than it sounds. It sounds hard, but it's way easier than doing this up here. All right, first, bring down the 2. There it is, 2. Now I'm going to go back up in this direction. Whenever I cross the line in this diagonal direction, I always multiply by 3. So 2 times 3 is 6.
Okay, I thought I was wrong for a second.
Now I'm going to add 6 and whatever number I have here. 0 plus 6 is 6. You just add them, and then we go back up. 6 times 3,
18.
let's go to 18. 18 plus negative 1,
17.
oh man, we're so fast at this. 17. 17 times 3,
51.
51.
51. 51 plus 3,
54.
54. I don't know what my color coding is. 54. 54 times 3,
162.
62, I said it first.
162. 162 plus this negative 2 is?
160.
It's 160. 160 times 3.
480.
Oh man. We're finally seeing the relationship between these numbers, these numbers and the numbers up here. Oh wow. So similar. All of these numbers right here, so similar. Wow. So cool. And then finally 480 plus 7 is
487.
I said it first.
487. Go ahead and always make yourself a line. Always make yourself a line right here. Because that last number will always be your remainder. And this is how you write your final answer. You start and go backwards. You don't start from the left, you start from the right. Starting from the left, I know that this is going to be 487 divided by what? Divided by this
X negative
x minus 3, I agree. Next up, I have my ones place, 160. So this is going to be added to 160. Next, I go to my degree 1 term. This is going to be 54x. So 54x plus 160. Next comes my x squared. So what should I write here? Shout it out.
17x squared.
17x squared. Next comes my x cubed place.
6x cubed.
6x cubed. And we're adding these in between. If there's a negative down here, then it's going to be a minus sign. And then finally, I have a 2x to the power 4. Notice our answer down here matches exactly with our answer up here. With far less work, far less space, but the same roughly amount of addition and subtraction and multiplication, all of that. Yes?
Where did you get your positive 3?
Where did I get my positive 3? This right here? I take, and that's a good question, everyone. This question, I take this number right here and I multiply by negative 1.
Always by negative 1.
Always by negative 1. You just flip the sign. All right. That's synthetic division. It's amazing. Fiona.
What would we do if like the thing that's being divided is like x to the second or something?
Yeah, so if you have x to the second, it won't work because we don't have an x term. Yeah, this only works with things of the form of x plus or minus some number. If I have 2x squared or anything with x squared or anything in front of the x, it doesn't work. It works for a very minority of the problems, but for the problem set tonight, it's the majority. So you can use synthetic division quite a few times on the homework set. I think there's only 1 or 2 problems that you cannot use synthetic division on. Let's try synthetic division again on example 2. Oh, sorry. Let's try synthetic division again. Oh, wow, I did the same exact divisor. Whatever. Or same, I don't know if that's called the divisor, but oh well. Synthetic division, on an easier problem, it will go much faster. You guys are telling me what to write. Tell me what to write. Set up this problem, example 2. And by the way, how much time do we have left? We are out of here at 2:18. We have 17 minutes left.
James, I never get called on. Actually, never mind.
James, go for it. Oh, let's go ahead and use synthetic division.
Okay. So your number would be 3 that you multiply,
3, okay.
and then it will be 2x squared minus 5x plus.
And again, we just need to write the coefficient. We don't have to write the x squareds.
Oh, sorry. 2 minus 5,
6, and then draw the line. All right. Thank you, James, for setting up the problem for us. All right. So let's go rapid fire, and I'm just going to do a blanket amount of XP at the very end of the lesson. Rapid fire. What is the first step?
Bring down the 2.
Yeah, we can just shout them out now.
Okay.
Bring down the 2. Next step.
Multiply by 3.
Multiply by 3, going up to the right, and I get 6. 6 plus -5 is?
1.
I get 1. Next step is to
Multiply by
3.
multiply to get 3, and then next step is to...
9.
James is on it. All right, where do I draw my bar?
Before the 9.
Right here. Draw a giant thick bar so it doesn't look like a 1. All right, and then I go in reverse order, and I write down my answer. My answer is, what's on the right?
9
over. Sorry, x minus 3.
Good. Keep rapid firing them out.
1 is x, just plus 1.
Just 1 or just x?
1, it's just 1.
Just 1, and then
2x, 2x.
2x plus 1 plus 9 over x minus 3. There's your answer. Synthetic division. Oh man, it makes our lives so nice. That's it.
Why did you make us suffer the numbers?
I wanted to show you why synthetic division is so nice. You really appreciate it now. If I just went straight to synthetic division, you'd be like, oh, this is horrible. But now you're like, oh wow, this is amazing.
Yeah, I thought we were gonna do that.
All right, our last and final example. This one is slightly different, and there are 2 traps on this one. Let's see if we can avoid each of them. Help me set up the problem. Someone aside from James. -3, -2, 2.
4.
Yep, okay. We fell for the first trap. All right, so that's wrong.
What do you mean?
We fell for the first trap. James, talk to us.
Would you put it as 2 cubed?
No, not quite, but a good attempt. Andre?
You use 0?
Yeah, we forgot our 0.
Oh.
Our degree 1 term, our
Wait, why
x
did you
term,
use
was
0?
missing. We had no x term. So look up here, Chris. We had no x term.
There's an x right there.
That's an x squared, and that's an x cubed, but we had no x term.
What do you mean there's no x
I was
there?
in the bathroom.
So that means we had to add a
Wait,
0.
Mr. Sinel, there's x's right there.
Oh my
No, I'm sorry.
We have to have a 0 here. And then a -5. Okay. And we draw the line. Bloop. You have to do the sound effect. There it is. All right. Rapid fire them out. Go, go, go.
Bring down the 2.
Wait,
Bring down the
I'm
2.
ready! Hold on!
Multiply
Oh.
by -3.
Hold on, we're going to pause.
-6.
Chris. Yes, you are correct, Chris. It is -6.
-2. And then
you
shut up.
multiply it
Wait,
by
3 is 6. It's just
so
6.
it's going to be 6, and then you plus it by 0, so it's just going to be 6.
Oh man, we're just.
And then so 6 times
It's
-3.
23. It's
It's
negative.
going to be
It's -20.
-18.
-23.
Where do you get 23?
-23.
Yeah.
And
Where the heck
then
did you get 18?
All right, everyone check to make sure that your synthetic division looks like Mr. Sindel's. By the way, you don't need to write the arrows. I write the arrows just so you can follow my work. You don't need to write the arrows if you don't want to.
23, and then you put
Maybe that's a good idea.
the big slash before the 23.
A big slash. All right. Sound effects make the world a better place, I believe. All right.
And
So-
it's -23 x plus 3. Or x plus 3.
Oh my gosh, this is
2
And then it's plus 6.
No.
And then it's -2x.
My head is turning.
All right. So, Chris, James, you are amazing individuals. We're going to give it to the rest of the class because you've been participating so well, and I really do appreciate it from the bottom of my heart. Thank you. We're going to give it to the rest of the class, and we're going to be a little bit more organized about shouting this out. Don't try to argue with each other. Go ahead and tell me what to write.
Okay, so you're gonna add 6.
6, and we got this.
Yeah, that's also gonna be like there's gonna be a plus 9 in between
I guess there's a plus sign, or you could have done it like this. You could have said like a. Why does it do that? You could have done a minus right here, or you can do a minus in the numerator. And then next sign is someone aside from Eva.
What?
-2.
Yeah. Okay. So.
X plus.
X plus, good. And then finally we have.
2x squared.
All right. Well, Chris, I didn't want you to participate because other people need to, but thank you. You have it correct. That's not HP.
Mine is HP. Dang it. Plus.
No, I appreciate all the positive feelings that we have today. There it is. Any questions on today's lesson? Synthetic division is nice, but sometimes you do have to do it the old-fashioned way over here.
I'm not doing that. There's a
Make
way where I
sure
can do
that you're always checking, is it of this form? Is it x plus or minus something?
Wait, why do I have to do it like that?
Whenever you do it like this, is of these following forms. So go ahead and write this on the front side. If you see something like 2x plus 1, you can't do synthetic division. If you see something like x squared plus 1, you can't do synthetic division. It has to be x plus or minus
Oh, right, you already said that.
one number. Yeah, it's good to reiterate, though, because that is probably the most important part of today's lesson. You guys have synthetic division down, but you haven't quite seen when to apply it and when not to apply it. So that's the part I'm worried about. But I'm pretty sure everyone in here got it. Good. We fell for a few traps today. No, that's good, because we learned from doing that. So you helped us learn. And that concludes today's lesson.